Here, we're going to use the idea of properties being preserved by isomorphisms to show that the integers mod 8 is not isomorphic to the direct product of z mod 2z and z mod 4z. And so what we're going to do is we're going to use the fact, and I'll write it down. So the fact is that being the identity elements is preserved under isomorphism. And so if you recall from the notes, this idea of being preserved means that if you have a function f from R to S, and so I'll write this down, if f from R to S is an isomorphism, and A has a property, then f of A has that property. And so A has this property in R, so that f of A has this property in S. And so this is what we mean by being preserved by an isomorphism. And what we're focused on in this particular example is that being the identity element is preserved under isomorphism. So this means that if we take the identity in one element R, if we take the identity of a ring R under a ring isomorphism, then that identity is going to map to the identity of S. And so how can we use this in this particular example? So we consider Z mod 8Z. And so here, just going to have Z mod 8Z here, and then Z mod 2Z times Z mod 4Z here. And so what are the units? So the units of the integers modulo 8 are 1, 3, 5, and 7. Here, the units in the direct product are going to be 1, 1, and 3, 1. Excuse me, I wrote that in the wrong order. 1, 3. And so if we have a isomorphism between these two rings, so if f from Z mod 8Z to Z mod 2Z cross Z mod 4Z is an isomorphism, each unit of Z mod 8Z will map to a unit of Z mod 2Z times Z mod 4Z. And we see here that this just can't practically happen. We've got 4 units in Z mod 8Z, but we've only got 2 units in Z mod 2Z cross Z mod 4Z. And so we can't have Z mod 8Z be isomorphic to any ring with less than 4 units, or any ring rather that just doesn't have 4 units. It's got to be isomorphic to another ring that has 4 units. Since this ring only has 2, we can't have an isomorphism. And so the reason this is important is because we don't have to go through all of the axioms that we have to show that something is an isomorphism. Those can be a bit tedious. You have to define a map. Here, all we're using is the fact that because an isomorphism preserves this property of units, then, you know, these two rings can't be isomorphic. And as I finish, I noticed that if we look up in the fact of what we're using, being the identity element is preserved under isomorphism, I want to replace this with being a unit. That's what should have been there in the first place, so being a unit. Okie dokie. And so I think that's all we have to say here. We can write one more note. So since the first ring has 4 units and the other only has 2, F cannot be an isomorphism.